Thanks, Alan. So thanks for the intro. Yeah, so my name is Charles. Let me give a little intro about myself before I start. So as Alan said, my name is Charles. I work with Adobe. I actually work with the identity team. So interestingly enough, I don't really do a whole lot of front end, at least not now. I work mostly in the back end, but in a previous life, I used to do a whole lot of ECMA stuff. Anyway, so I have 3 points of contact. You can reach me on my blog, my Twitter, my GitHub. So feel free. I love hearing from everyone. So, what can we expect today? So we're going to talk about puzzlers. Is anyone familiar with Java Puzzlers by Joshua Block? No? So I'll explain what a puzzler is, but essentially I have five of them lined up for today. Hope we can get through them. We don't have a whole lot of time. The last time I did 4 in about 40 minutes, so we'll try and go through these quick. We will also be talking about pure JavaScript. So no libraries or no third-party frameworks and nothing like that, which leads into what we're not going to be talking about. Anything third-party, anything external. No jQuery, no Node, no Backbone, nothing like that. We're also not going to be talking about bugs. So everything that you're going to see is as designed by the language specification, by the ECMA specification. Okay, so what is a puzzler? In short, a puzzler is a very simple programming puzzle that demonstrates or exploits weird behaviors and quirky edge cases of a given programming language. In this case, JavaScript. So essentially, it's going to be a short snippet of code, anywhere from like 5 to 15 lines of code, and it's going to demonstrate something weird about the language that you might not be familiar with. How is this going to work? Okay, well, there's 5 steps. First, I'll introduce the code. Like I said, it's going to be very short. You should be able to figure out what it does, or at least figure out the notion of what it's supposed to do. Second, I pose a question, a multiple choice question, and you try and guess what the answer is. Now think hard, because it's not always intuitive. In fact, it's never intuitive. Third, I give a walkthrough. I give a naive walkthrough. So that's to say that I give a walkthrough from the perspective of someone that doesn't know the puzzler. 4, I tell you the answer, and it may surprise you. 5, I tell you the moral and how you can avoid making mistakes like these in your own code. So let's begin. Actually, before we start, how many people here, just a quick survey, how many people here work primarily in the back end? Okay. And primarily front end? Most people, okay, cool. So here's my first puzzler. I call this, That's Odd. So take a look at this. It's about 15 lines of code here. So take a look at this and try and figure out, what does this print? So I'll give you guys a few minutes to discuss. So yeah, feel free to talk to your neighbor. Feel free to discuss around you. In a few minutes, I'll take a vote. So quiet in here. All right, let's take a vote. Everyone have an answer? Who thinks it's A? B? Folks. C? D? E? And F. All right. Looks like B, E, and F are the answers. Okay, so let me give my walkthrough. All right, so let me take a look here. So it looks like we have a self-invoking function. We have a variable values, which is an array of 5 different values. We have the number 7, the number 4, the string 13, infinity, and -9. Then we have a for loop, which is going to iterate through this array. And for each value in this array, we're going to call isOdd. And in isOdd, we return num modulus 2 equal 1. So we're checking to see if the remainder is 1, essentially checking to see if the number is odd. Okay, so let's see. So for 7 mod 2 should equal 1. So that should display. 4 mod 2, that should be 0, so that won't display. The string 13, I think, will cast correctly, and so I think that is odd as well, and so that should display. Infinity mod 2, so I'm not sure what JavaScript will do here, but just from math class, I should know that this should not work. So I'm going to say that won't display. -9 mod 2, is -9 odd? Yes, so I think that will display as well. So I think 7, 13, and -9 will display. So my answer is E. So let's see what the real answer is. Hello? B. All right. So what happened here? Why didn't -9 display? So let's take a closer look. So here are our values. So 7 mod 2, that's 1. That displays. Good. 4 mod 2. Oh, that's 0. That's a typo. That should be 0. That should not display. 13 mod 2, that's 1. Okay, so that displays. Infinity mod 2, not a number. Okay, doesn't display. That's good. -9 mod 2 is -1. So that does not display. So what's going on here? Essentially, JavaScript shares the same behavior as the Java implementation of the modulus operator. So that means that it satisfies, or it must satisfy this identity equation in order for it to be true. You don't really need to understand the equation the important thing is the side effect of it. The side effect being that the result will have the same sign as the left operand. And so knowing this now, it's easy to see why our program fails on -9. So how do we fix this? Well, instead of checking for equality with 1, we could check for inequality with 0. So that should work. Bonus points for anyone else who knows the quicker way to check if a number is odd. I think I heard it. Bitmask? Yeah, there you go. Awesome. Cool, so the moral, be careful about the signs, be careful about your signs when using the signs of operands when using the modulus operator because it matters. All right, on to the next one. I call this one the 1. So take a look at this code and tell me, what does this print? So again, I'll give you guys a couple minutes and we'll take a vote. All right. Everyone have an answer? Let's take a vote. Who thinks it's A? A few people. B? No one? C? Oh, man. Everyone knows this one. D? Or E? Okay, so I'll give my walkthrough. Okay, so we have a self-invoking function here. Another variable, people, with 3 values, 3 strings, Trinity, Neo, and Mr. Smith. We have a for loop, and it's going to iterate through this array, and for each value in the array, it's going to, first it declares a variable is the one, and since it's not initialized, it should first start out as undefined. Then we have an if statement, and it's going to check if the person's name, or if the person's name is Neo. If it is, then it's going to set the flag is the one to true. Then there's another if statement, if is the one, which should only be true for Neo. It will alert person's name, you are the one. And since Neo is the only one with the name Neo, I am going to say that it will only print Neo, you are the one, A. So what is the real answer? There we go. C. So no surprise, looks like everyone knows what the answer is here. Next slide. So why is this? So for those that don't know, there are really 2 concepts that are happening here, and I'll explain them. First, there's no block scope in JavaScript. So if you're familiar with, or if you come from a Java or C++ background, you'll look at something like this for loop here, and you'll look at the variable I, and you'll think that you'll be used to knowing that the variable I has scope only within those parentheses. But since there's no block scope in JavaScript, I exists there. The second thing that's going on here is a procedure called hoisting, which I think everyone's familiar with here. So again, if you come from a Java or C++ background, that variable I is restrained to be within those parentheses. But because of the procedure known as hoisting, I is available there too. It exists there too. So what's going on here? Well, what happens is the compiler, the interpreter, will take any variable declarations and move them to the top of the function. But it leaves the assignment where it is. And so it essentially looks like this. So notice that the variable I moved to the top of the function, or the namespace, whichever namespace they're in. And, but the variable declaration, the assignment stays where it was. So I exists there. But what's the value of I? Well, it's undefined. And so knowing that now, we can easily see what happens here. Applying that same logic, we see that the declaration of the variable is the one got hoisted to the top of the function. And now we know that it doesn't get reset every time the for loop iterates. So the declaration became hoisted there. And so it's easy to see now with knowing this why we get the answer we do. So how do we fix it? Well, let's put an explicit assignment there. And so that should do it. So the moral, there is no block level scoping in JavaScript. Douglas Crockford always mentions this. Declare all of your variables at the top of your function. That way you get no surprises when you're hoisting, or no surprises with your variable declarations. All right, on to the next one. I call this loop-de-loop. So take a look at this code and tell me what it does. And so a couple things I should mention for this puzzler. There are 2 special things to note. So that number is not just any number. It's a special number. It is 2 to the 53. And the second thing to note is this for loop is special too. Traditional for loop is, I equals start I less than end, I plus plus. This is I less than equals end. So that should affect your count too. So I'll give you guys a couple minutes and try and figure out what this does. All right, let's take a vote. Who thinks the answer is A? A few people. B? A few people as well. C? D? A few people there. E? And F. All right, most people. All right, so let me give my naive walkthrough here. So we have a variable end, and it equals 2 to the 53. Then we have a variable start, which is end minus 100, a variable count, which is 0. And then we have a for loop that's going to start at 2 to the 53 minus 100 and go until it equals 2 to the 53. So it should count up 100 times plus the one more for the equality. And so I believe it should count 101 times, and so it should alert 101. So my answer is D. So what's the real answer? So it's F. So it enters an infinite loop. So why does it do this? Well, to understand this, first, 2 to the 53 is a special number. Why is this special? Well, first we need to understand a little bit more about how JavaScript represents numbers. So JavaScript abides by the IEEE standard for floating point arithmetic, the IEEE 754 spec. So for those that know, it's also the same spec that Java uses for the double floating point type. So as such, all numbers in JavaScript are represented in this format. So we have a number, and then a number which is represented by some integer multiplied by an exponent. In this case, the base is 10. But in binary, this is how it's represented. So we have 64 bits to represent the number. We use 1 bit for the sign, 10 bits for the exponent, which leaves 53 bits for the mantissa. What does that mean? It essentially means that we have 53 bits to represent integers. Essentially, it says that 2 to the 53 is the largest exact integral value that can be represented in JavaScript. From the ECMA specification, note that all positive and negative integers whose magnitude is no greater than 2 to the 53 is representable by the number type. What does this mean? Well, var num A equals 2 to the 53. Num B equals num A plus 1. Num A triple equals B is true. So what happens here? Well, we have num A, which equals 2 to the 53. Num B equals 2 to the 53, and we add 1. And what happens is, as soon as we pass 2 to the 53, it adds the number, but we immediately lose that precision, and it rounds back down. And so it will perpetually stay at 2 to the 53. We'll never pass that threshold. Well, it will, but we lose the precision of 1 past the threshold. So knowing this, we can, again, easily see where our problem is. So how do we fix it? Well, let's not use 2 to the 53 as any type of range for our loops. So a bit of a contrived example, but just to illustrate the point. So the moral, be aware of your number representations. If you're working with anything big or anything important, if you're working on cryptography, you're factoring large primes, anything like that, be aware of your number representations because they impose real limitations on your program, on your application. So, my next puzzler, I call it, why are we bankrupt? So take a look at this code, and can you tell me, what does this print? Are you ready to vote? Who thinks it's A? A few people. B? That's a handful of people. C? Again, a few more people. D? E? Okay, looks like B or E seem to take it. All right, so let me give my walkthrough here. So we have a variable, cost of candy, which equals 0.6. 60 cents. Then we have a function, calculate change, which takes a cost and a paid, and it's going to return paid minus cost. So, real simple. Then we call calculate change with the cost of the candy, which is 60 cents, and we pay with 80 cents. And so paid minus cost should be 20 cents, 0.2. It's not a string here, so I think it will print 0.2. B. So what's the answer? Looks like it's E. So none of the above. It prints 0.20007. So what happened here? So as we learned from the last puzzler, all JavaScript numbers are represented using the IEEE 754 spec. Because of this, values are not represented exactly, but rather as a fraction. So for instance, some non-integer values simply cannot be expressed exactly in this way. So for example, 123.45 can be represented by 12,345 times 10 to the minus 2. However, 1 over 3 cannot be expressed exactly in this format. It has to be approximated. So how do we fix this? How do we address this for this application? Well, when dealing with money, the answer is simple. Deal in terms of cents instead of in terms of dollars. So instead of using 0.6 to represent 60 cents, we should use 60 to represent 60 cents. So why is this? Well, let me go to the moral here. Floating point arithmetic can be inaccurate when representing fractions, so when dealing with money, you deal in terms of cents. This makes all of your calculations integer calculations, which are exact. Not completely exact, though. Remember from our last puzzler, it is only exact up to about 2 to the 53. So as long as you're dealing with anything less than 9 quintillion, you're okay using integer arithmetic. So I have one more puzzler. I'm running out of time here. It's called the Prestige. So take a look at this code and tell me, what does this print? All right, let's take a vote. Who thinks it's A? Handful of people. B? Handful of people. C? A few people. D? Couple takers. E? Looks like E takes it. All right, so let me give my naive walkthrough here. Okay, so we have a global variable, name, which equals Mr. Bond. Then we have a self-invoking function, inside of which we only have an if-else statement. The equivalence expression in the if is type of name equals undefined. So it's essentially checking, is name defined? If it is undefined, it will drop into the if statement, declare a variable name equals Mr. Bond, and then invoke say hello with the name Mr. Bond. So what does say hello do? Well, it looks like it alerts hello plus, and then a ternary operator here. If name is defined, then output name. If it's not defined, output Mr. Roboto. So if you call say hello with Mr. Bond, it should say hello, Mr. Bond. So if name is defined, it should say hello, Mr. Bond. If name is undefined, if it's undefined, it should say hello, Mr. Bond. If it's defined, it should say just Mr. Bond. So I say my answer is, well, since we have a global variable here, I think it is defined, and so it should just say Mr. Bond. But actually, let me change my answer here. From our second puzzler, we know of a procedure called hoisting, so this variable name should actually be hoisted to the top of the function, and the assignment should stay where it is, and so I believe that name equal undefined should actually hit. That should be true, and it should fall into the if statement and invoke say hello. And so it should say hello, Mr. Bond. So my answer is A. So what's the real answer? So it's B, Mr. Bond. Okay, so what happened there? I thought that hoisting would have made it say hello, Mr. Bond. Okay, so again, let's take a look at the reasons for this. So let's remember that there's no block scope in JavaScript, and also there's a procedure known as hoisting. So looking at this, let's apply hoisting to our application. So we see name moves to the top of the function. it's going to fall into the if statement, assign the variable name, Mr. Bond, and invoke say hello name with Mr. Bond. But that still seems to print Mr. Bond. So what's going on? It must be something in the alert. So let's take a look at the contents of the alert. So it says, hello, if name is undefined, then print Mr. Roboto. If it is defined, print name. But order of operations dictates that the binary plus operator from the ECMASpec takes precedence over the conditional question mark operator. So what happens here? Type of name, not equal undefined, is going to be true. But since plus has precedence, we're going to get that. And hello true is always going to be true because it's not null. And so we get that. So according to the MDN, the binary plus operator has precedence of 6 while the conditional operator has 15. So this is actually below most of your common operators. Plus, modulus, even bit shift. So how do we fix it? Well, do what Douglas Crockford said, and let's move all of our variable declarations to the top of the function. So that fixes the hoisting problem. How do we fix the ternary operator problem? Well, just proper placement of parentheses. So I just place proper parentheses around this, and it just encapsulates it. That's it. So the moral, don't forget about hoisting. Order of operations matters, and be explicit and place parentheses where you need to. Correctness is more desirable than readability. So. Sorry, was it? Oh. That's not a trick. Sorry, that's not part of the trick. I just didn't name it, sorry. So anyways, that's it. So thanks for listening.